In this video, I'm going to be working through the 4.6 homework exercises on web work. These problems deal with exponential growth and decay. And so problem 1 says that the half-life of strontium-90 is 28 years. How long will it take a 72 milligram sample to decay to a mass of 18 milligrams? So this problem tests our knowledge of what a half-life is. So strontium-90 and other radioactive elements will decay in a certain amount of time, and a half-life is defined as the amount of time it takes for half of the original amount to decay. So if we have 100 milligrams of strontium in 28 years, you'd only have 50 milligrams of strontium-90 and then 50 grams of other stuff. So if we start with 72 milligrams of strontium-90, then that would be after 0 years. Then in 28 years, we would have exactly half. So half of 72 milligrams would be 36 milligrams. And then in another half-life, so in another 28 years, so that would be another 28 years would be a total of 56 years, the amount of strontium would be cut in half again. So go from 36 milligrams down to 18 milligrams. And so this problem, you don't need any complicated formulas. You should end up with a nice whole number answer and numbers of multiples of 28 years. So in 28 years, you go down to 36 milligrams, and then another 28 years, you go down to 18 milligrams. So that was after a total of 56 years. Okay. All right, for problem number 2, we're asked to find the doubling time for a city whose population is growing by 23% per year. The doubling time is defined as the amount of time it would take for the population to double in size. And you notice we're not given the actual size of the population because you don't need that to actually calculate the doubling time. This is an exponential growing city, so we use our exponential growth formula, A equals P times 1 plus R to the T, and we're given that the growth rate is 23%. And we always use the decimal form, so we use 0.23 for the value of R. So the exponential growth formula would be A equals P times 1.23 to the power T. And we're trying to figure out how long would it take for a population with P people in it to double in size. So to double in size, that would be the same as 2 times P. So we want to know when is the accumulated amount of people equal to twice the population. So we plug in 2P for A and solve this for T. So the first thing I'm going to do is divide both sides by P, and you see that when all the P's cancel, we'll just get 2 equals 1.23 to the power T. So you see it doesn't really matter what the initial population size was, because we're just going to end up with this equation, 2 equals 1.23 to the T. So this is an exponential equation, so I'm going to convert this to a log equation. We get the exponent T would equal the logarithm base 1.23 of 2. So you can type this expression into a graphing calculator, and you would get approximately 3.3483. So a city growing by 23% per year would take about 3 1/3 years to double in size. Problem 3 says find the half-life of an element which decays by 3.41% each day. So again, the half-life would be the amount of time it would take for half of the element to decay. And we have an exponential growing quantity, in this case the growing exponentially decaying quantity. So we still use our exponential model here. And since r is a decay rate, it's actually negative 3.41%. And so when we plug in the decimal form, I'm going to plug in negative 0.0341 for r. So we plug that in for r. 1 minus 0.0341 to the t. And when I simplify this, I get p times 0.9659 to the t. So here is our exponential decay model, and we want to know how long will it take for the original amount p to decay to half as much. So we want to know, when will the accumulated amount a be equal to half of p, or p over 2. So to find a half-life, we actually plug in p over 2 for a. So now solving this equation for t will tell us how long it would take for the original amount p to become half of p. So just like we did in the last problem, I'm going to divide both sides by p, and that'll cancel the p's, and so we get 1/2 equals 0.9659 to the t. And to solve for the exponent t, we need to convert this to a log equation. T will equal the logarithm base 0.9659 of 1/2. And when we enter this in a calculator, you would get approximately 19.9783, and that's days. So it would take approximately 20 days for the original amount to decay by half. That's the half-life. So I'm going to enter 19.9783. There we go. So for problem number 4, we have to use carbon dating to determine how old an artifact is. It says a wooden artifact from an ancient tomb contains 60% of the carbon-14 that is present in living trees. How long ago was the artifact made? And we're told that the half-life of carbon is 5,730 years. We're given this formula that T is equal to 5,730 times the natural log of C, where C is the amount of carbon left as a decimal, and then you divide that by a natural log of 1/2. So for our problem, we have 60% of carbon, so we're going to plug in 0.60, or just 0.6 for C. So in this formula, I would do 5,730 times the natural log of 0.60 divided by the natural log of 1/2. When I evaluate this expression, I get 4,222 years and 0.81 years. So this is a rough estimate here, so we don't have to be too accurate with the decimal places. So if we just type in 4,222.81, submit, we get a correct answer. So it's important when you're plugging in the number C here, you're using the decimal form of, so if you have 60%, you type in 0.60 and so on. And that finishes the section 4.6 homework.